Okay, one more mention about composition. This is what we did as the last example from Monday. It looks a little bit messy because things are actually quite complicated, so I encourage you to maybe watch that particular part of the recording and see how we can build an object structure like this from scratch. Okay? For that one, I'm going to leave that to you. Now, I do want to just give one more example about composition topic. Okay? Let's take this guy over here. So this is what we got over here. This guy here basically define a copy constructor, which will do the deep copy as we learned from Monday. So now, I'm going to change only a bit to this particular copy constructor, and then I'll pose a question to you. Okay, over here. That's clean. Okay, so now we are talking about the same copy constructor over here, and then we are changing 2 bits over here. So now you can see we still have this line in the body of the loop, but now we don't have this line anymore. What we do is, whatever source file that we got from other, which we want to copy from, the files at position I, we simply do an assignment over here. And then we simply put this source file inside the add file. Okay, that's what we do. And now I have a question for you. If we are doing this second version of the copy constructor for something like a deep copy, is composition going to be maintained or violated? So what I mean is there any possibility for aliasing in this new edition? Any idea? Is there going to be any violation for the aliasing? So that could be a typical question I can put on lab test 2. Okay? I can just give you the code over here, and that might compile. You can feel free to try on Eclipse, but you have to explain to me why the composition might be violated, right? Let's try that all together. Yes, anything? Which file? You mean which variable? Source, okay, very good. You can see this line is really the key. What we did before previously, once we get a source, we actually call the copy constructor for the file class, which is going to make a copy for the file. But now, we don't do that anymore. We get rid of that line. So we simply just pass the source directly. Okay? So now let's go a little bit further. Your intuition is absolutely correct. But now, I got a second question for you. How do you write a test case, a JUnit assertion, that is going to be violated, which shows it violates the composition, right? So where exactly is the aliasing, right? Okay, so now I just want to show you the thinking process over here. So let's draw a diagram very quickly for this new version of the copy constructor, and then we are done with the composition. Okay, just more like a recap. Okay, let's do it again. So now let me just undo the mark over here, so we don't need them anymore. Okay, that's a new version. Okay, let's do that very quickly, just for one or two iterations. So we already got some starting diagram. So now I want you to look at over here these 2 lines. Basically, we're creating a new directory called D1 over here, which is a directory objects. And then it has the name called D, so D over here. And then we are trying to add 3 files, F1, F2, and F3. And you can check your notes. The way we add a file is by calling the copy constructor for the file class, which means you can create a file objects. So this is the first file objects. That's the second one. That's the third one. And we have F1, F2, F3. That's how we started. Okay? Now, let's see this particular line, which is important. Let's look at this line here. When I say directory D2 is assigned to new, every time after new, there should be a constructor call. But now we are doing the copy constructor. In this case, it's D1. So now, how do we exactly make this copy here? Okay, let's try all together. Basically, what we will do is, for this one here, first of all, you can see there's a new keyword. So we're going to have a D2 objects. So D2 is going to point to a directory objects. And then we know that for every directory, it has a name, number of files, and also an array of files. To begin with, it actually got maybe just 0, 1, 2, all the way to 99. Okay? That's how we started with. Now, what we want to see is over here. So this is basically what the green line would do. So when we call the copy constructor over here, this part here, as I said, if you simply use the this keyword, is calling other version of the constructor, calling the helper constructor. That's what the green one would do. Now let's enter this loop. That's really the key. That's a loop. Okay? Let's only try the first iteration, and then we can extrapolate for the other 2 iterations. For the very first iteration, this is how it's going to work. So we have integer I will be initialized to be 0. So that means I will be 0 over here for the pink one. And now what this means is we're going to go to other. What's other in this case? Other is simply just D1. Agree? Okay, other is simply D1. So I'll put D1 over here. So source is going to be assigned to D1.files at position 0. What is that? So D1.files at position 0. D1.files at position 0 is over here. So we are talking about this particular file objects. Okay? And then we are saying that whatever that object it is, we're going to copy its address into another variable which is local called source. Okay? And then, so that means this is what we're going to have. So source is going to be here. It's going to be here. So you can see that there's no file created, no new file created whatsoever just yet. Okay? And then in this new version over here, we simply say this dot add file. So this simply is D2. Okay? That's a context object. So that's D2. So D2 dot add file and source. Okay? So the add file that we're talking about is over here. Add file. We simply just do a simple assignment. Whatever f you pass, call by value, remember? And then we're going to increment the counter. So now, are we creating any new file in this case where we say add file? Not really, right? Because over here, you can see there's no new keyword used over here. So that means what we're doing is NOF at the moment is simply just 0 to begin with. So that means this position here is going to point to wherever the source file is pointing to. So that's where the aliasing is occurring. Okay? That's the first iteration. What about the second iteration? It's going to be done in the same similar way. So I'll just use a different color to show you. In the second iteration, the I will be incremented to 1. So that means at position 1 is just going to point to this file over here. Okay? Similarly, for the third and last iteration, it's going to be position 2 is going to point to this file over here. So now, what kind of test do you have to write to show there's a violation for composition? One example could be, I'll write it here. What you can do is write it in orange. You would say assert true if there was composition. That means there should be no aliasing. That means file at this position here and file at this position here should not be referring to the same objects. They should not, right? So what I would say is, for example, you can say D1 dot files at position 0 is not equal to D2 dot files at position 0. So this assertion here is meant to assert that there's composition, but in this case, it's going to fail because they do refer to the same objects, right? Okay. Okay. Once more, you can see that they do refer to the same objects, the same. So that's going to fail. So no, it's not composition. So we have seen 2 versions of the deep copy-like copy constructor. So one is this, which is not exactly composition, and this is really composition, as we saw last time. Yes. Oh, because, okay, good question. Why am I using this assert true over here as opposed to assert equals? Remember I said assert equals, that simply means when I say assert equals, let's say, when I say assert equals, let's say some expression 1, comma, expression 2. What you would do is you're going to say E1 dot equals E2, right? In this case, if the class for E1 has not overridden the equals method, that's okay. It's going to call the default version. But if it has already overridden the equals method, then you wouldn't compare the references. So to really check for composition, you want to make sure there's no aliasing. That's why we're using the equals to compare addresses. Yeah.
I get what's going on, but I missed the output of this other document.
Which one?
The green.
The green. Oh, that one simply like a call to the helper constructor. That's something we discussed on Monday. You can just review that part. Yeah, okay. Guys, any more questions about composition here? Okay, good. Let me just tell you what you should really look at. So now this is a simple exercise for you, which I believe you may got something similar for your practice test, but you can also try this method as well. What I want you to do is, given that we got a directory class, and also we got a copy constructor, what I want you to do, I want to have get files, and then return the list of files that's in this particular directory. But I want to make sure whoever gets this return value should not get any possibility of aliasing. That means you create a new objects for every file that's contained in the directory. Okay, that's a hint to you, but try that. All right, and finally, we're just summarizing about composition and aggregation. Okay, you can read it through. Everything we have covered already. Okay, one more thing. So when we talk about aggregation composition, they don't necessarily have to work independently. I'll just show you one real-life example. Okay? Aggregation basically allows sharing. Composition does not allow sharing. So sharing and not sharing may actually be mixed together. One example can be a little bit like your prison lab configuration. For example, let's say this. Let's talk about the workstation in your prison lab. Each workstation has its own keyboard, has its own screen, has its own CPU, right? But do they share anything together? For example, they share the network for the departments, right? But they don't share any screen, any keyboard, or any CPU together. So conceptually, this is, so you can think about the same network that's being shared is really aggregation, right? It's an aliasing over here, which means workstation number 1 is referring to this particular network, which just the same network as every other workstation. On the other hand, for CPU, monitor, and keyboard, their composition, they are not really shared between any workstations. Conceptually, that's what you get, okay? Basically, it's simply saying that, okay, you can think about this is one object for the workstation number 1. And then keyboard, CPU, monitor, conceptually, they are simply belong to this particular workstation exclusively. They are not shared. On the other hand, every workstation has an attribute called network, which points to the same objects for the same network, for the departmental network. Okay? So that's just one example to show you. You don't necessarily need to have aggregation or composition exclusively. You may mix them together, depending on what you need. All right, any more questions about composition? Okay, that will be the end of the coverage for your lab test 2. Okay? If you have no question, let's go on to the most interesting topic for 2030, I personally think. Since we talk about object-oriented programming, when you talk about object orientation, so far we talk about very simple stuff. Classes, objects, aliasing, a little bit asymptotic annotation, like a asymptotic upper bounds, but they are okay, they are just basic. But now this is where things get more interesting, okay? For today, I just want to give you a very first lesson about the first level about inheritance. We'll get to the core part for the whole next week, or maybe even extend beyond that. But it's gonna be beneficial for you. Okay, let's now have a motivating problem which we're gonna study throughout the whole lecture, okay? And I would like you to do me a favor, just spend about 1 minute or 2, read it over, okay? Now, let me just assume you know nothing about inheritance. Think about how you would design different classes for this particular problem over here. What methods do you need? What classes do you need? Okay, I'll give you 2 minutes, and then we'll talk about it together. And that's a task, of course. Okay, let's have another 30 seconds. At least you know what we are talking about. We'll keep talking about this example. it will definitely be programmed into your mind. Okay, everybody got a chance? Okay, now, let me switch to iPad. The same problem over here. Now, anybody want to volunteer? At least tell me what classes would you create? I heard students. Student course, okay. Let me highlight it. By the way, remember what we said back in the first year. It's a very general principle. When you are given informal description written in English like this, look for nouns. And the nouns may be turned into classes, attributes, or accessors. And also look for verbs, which may be turned into mutators. Okay, this is very general guidance. Not necessarily every noun has to be turned in this way, not necessarily. For example, you can see that data, in this case, don't have to be turned into a single class. Okay, anyone? Yes, go ahead. What class would you like?
Resident and non-resident.
Okay, basically, you talk about non-resident students and also resident students. Seems like two classes, right? Anyone else? Yes. I see what you mean. So you're basically, first of all, I see there are two things to your answer over here. First of all, when we talk about student management system, it's more like a point collector. It collects different kinds of students. That's the first stage. The second stage, you talk about two kinds of students. For two kinds of students, do you need a single class or two classes in your case? How do you use one class, but somehow you can distinguish between two kinds of students? So let me just go a little bit further. Actually, it's a very common way of thinking. Let's try, okay? Okay, let's say if I have a class called students, for example. You're saying that, well, I'm going to use the same template for both resident students, which got premium rates. Also, I got non-resident students, which got discount rate. How do I use a single class to accommodate both possibilities? David, go ahead. What kind of attribute? What type?
Even a string.
Even a string? Okay, sure. No problem. So basically what David is trying to say is, let me call it kind over here. What kind of student you have, and then at the runtime, for example, this may be, for example, I'll say R for residents, or it can be NR for non-residents, right? So now think about some case over here. And then, of course, you may have premium rates, and you also have discount rate over here. And then in the case of R, the premium rate should have some value. In the case of being non-resident students, the discount rate should be some value over here, right? So now what about the client's code? When you write some application code, given a student object, you have to check to see what kind of student they belong to, right? You can say something like s.kind equals resident students. If it is the case, I will do something over here. Else if s.kind, let me write it out. There's a reason for that. Equals non-resident students. And then I do something else, right? To discriminate. I can tell you that this might work for small scale system. But since we are now in second year, let's think a little bit beyond the code. Let's think more about design. Whenever you want to think about software design, you want to think about maintainability, especially when you want to extend this particular application. Let's say, rather than only two kinds of students, what if I got 50 different kinds of students? Well, at the student class, let's say I got 50 kinds of students. Let's say 50 different kinds of students. And then this attribute is okay, it's just a string value. I just need to have some unique string value for each kind. But what's going to be really painful is, for the clients, how many if-else if do they have to write? 50 different. Right? You may have to repeat such code structure for every client. So that's why this design is not so ideal. Okay? Let me give you a little bit preview. Okay? The good thing about inheritance is somehow this kind of if then else else if statements that you have to write explicitly without inheritance. With inheritance, you can let the runtime to resolve it automatically, but we'll get there. It's something called polymorphism and dynamic binding, but we'll get there. It's the topic for next week. Anyway, this is a very good first trial. It worked for small system, but not for big system. Okay, so that's one possibility. Okay, anyway, let me just present to you another possible implementation, which is also very common, and then we'll criticize about it once more, and then we'll move on to inheritance. Okay, let's go to the first one. Let me just use slide to show you. Okay, so let me just say one more thing. So basically what we're going to do, oh, that's not good, over here. What we're going to do is, we'll worry about student management system a little bit later. We'll get there. So we're going to have resident students, we're going to have non-resident students, and also they should be able to register a course. That can be a mutator. And, I forgot to switch. Sorry about that. Let me say it again. So we got resident students, we got non-resident students, and also we got the list of courses they are registered, an array of course. And also we can register them for a particular course, and also we can calculate the tuition. However, the way we calculate the tuition for resident students and non-resident students, they are not completely similar, but they are not completely different either. The base amount is the same. Add up all the course prices together. But for the case of non-resident students, you have to apply something called premium rates. For the case of non-resident students, you have to apply on the base amount some discount rate. That's kind of the roadmap. Okay, let's see the first trial without inheritance. Okay, let's say we have a class called resident students. Okay, and let's say we have attributes, name, registered courses, which is an array, and then we got number of courses. Okay, 3 attributes, makes sense. And we also have a premium rates, which is only specific to resident students. Okay, and also we have the constructor here. By the way, is that a copy constructor? No, right? Hopefully you know why, right? Because the string over here is not the same as resident student, so it's not a copy constructor. Okay, good. Okay, for the resident student, we simply initialize their name and also, let's say, initially 10 courses. Okay, that should be good enough. And then we also got the register method here. Given a course, we want to register that particular course for this student here. Okay, and also we have a method for calculating the tuition. Now, this part I'm showing you here is calculating the base amount. So starting the tuition from 0, run a loop over all the courses the current student is registered for, and then add up all the course fee together, right? And then what should we do further for resident students? Premium rates. That's exactly right. Okay, we just say whatever tuition it is, calculate premium rate. That's about resident students. So far so good? Okay. Now, without showing you the next slide for non-resident students, do you think the code for non-resident student will look similar or completely different to this? Similar. What will be the difference? Right, discount rate, and also maybe the constructor name should be different, right? Because it's a different class. And also for tuition, what should you multiply instead? Discount rate. Actually, exactly what I highlighted. That's the only thing you have to change in order to get to the other class. So what does that mean? There are different classes. That means you have to repeat basically almost the same code twice. But what if you have 50 kinds of students? You may have to repeat them 50 times. That's not good. Okay, I will explain that in just a moment. Okay, so that's about resident students. And then we got the second class, which is non-resident students, just a different name. And then we still have these 3 attributes. You can see we already got repetition, right? We got to redeclare these attributes. So that means it would be nice to really factor out everything that's similar between the 2 kinds of student into a single place. A little bit like this. I'm not sure if you can accept this analogy here. Think about what we're trying to do is like here. When I say 2x plus 2y, so I'm trying to factor out the common part and then say 2 and then x plus y. Okay, so we would like to put this in a single place. Anyway, that's a simple analogy, but we'll get there. Okay, 3 attributes, and then we changed it. Also, we have discount rate rather than premium rate for non-resident students. Also, we got non-resident student constructor here. You can see the body of the constructor is just the same, And then we got register, and the register method for this kind of students is just the same as the other kind. And we also got get tuition, which basically 90% of that is the same. And the difference is we have to apply this base rate to the discount rate instead. So the yellow part is the only thing that's not repeated. The rest is simply repetition. Okay. So now, let me go to the next slide. By the way, any question about these 2 classes? Maybe we should do some tester soon. Let's do some tester very quickly. Okay, what I will do is, let's go here. Okay, so these are the 2 classes we have just seen. Okay, so nothing is new. But we're going to run some tester very quickly, just to see how things will work together. Okay, so now the first 2, we're simply creating C1 and C2, 2 course objects. Let's assume we already got a course method defined, the course class. I believe it's over here. Let's assume we have a course which got title and fee and also constructor. Very easy class. And then let's say this. We got 2 courses. One is 2030, the other one is 3311. So 2030, 3311 is already there, C1 and C2. Let's see the rest. First of all, let's try to use blue. This line over here, resident students, Jim. Okay, and then we're gonna do very soon, also non-resident students, Jeremy. That's what we will do. Let's see exactly how they will be executed. So now for the first one, Jim is going to be a new resident student with this name. So that means Jim is going to point to a resident students. Okay, I'll say RS for resident students. And then we got name, registered courses, and number of courses. These are the 3 attributes. That means we have name, number of courses, and also registered courses. I'll say CS for courses. So these are the 3 attributes. Okay, and then the name will be okay. I'll just assume it's going to be this name over here. And what's more, we also can set the premium rates for this particular resident student, right? We also got premium rates. So that means we got another attribute here called premium rates. In this case, set it to be 1.25. 1.25. And then initially, we simply got an array of courses over here from 0, 1, all the way to 9, 10 courses to begin with. Okay? And let's now do some registration for Jim. We say Jim.register for C1, 2030, and also Jim.register for C2, 3311. So what that will do, you should be very familiar with this. The first course for Jim should be pointing to C1, and the second course should be pointing to C2. Okay, very good. And now let's do the same thing for Jeremy quickly. So now we're gonna do the green one over here. So that means we have Jeremy over here is pointing to a non-resident students objects. Non-resident students over here. And now how many attributes do we have for non-resident students? 3, are you sure? Or 4? 4, right? Because we got name, registered courses, number of courses, and discount rate. All right, don't forget. Let's do that very quickly. It's gonna be similar. Okay, we got name, number of courses, and also courses, and discount rate. It's gonna be DR. Okay, and we'll set it to be 0.75. Okay, 0.75. And then let's have them become classmates. So C1 and C2 also to be registered for Jeremy. That means over here, I'm just gonna draw the array over here. Okay, it's going to be the course array for Jeremy. So 0, 1, and all the way to 9. Okay, and now how do we register? Well, we're simply going to say for this particular position for the course, it's going to point to C1, right? So now it's going to be a little messy, but let's try. This is going to point to C1. Okay, and the second course is going to point to C2. So So now you can see that the first course for Jim and the first course for Jeremy, they're aliased, right? That's what we learned about aggregation. Finally, I would like you to see the most important two lines over here. How do we get the tuition for the two? When I call Jim.get tuition versus Jeremy.get tuition, okay? We got two lines over here. Let me call that over here 1 and 2. To execute the get tuition for line for 1, which version of the get tuition am I going to call? On the left or on the right? For 1. When I say Jim.get tuition, apparently we got either get tuition over here on the left, or we also get tuition on the right. We got two versions over here. Which version is it going to call? The left, right? Because Jim is of type resident students, right? It's going to call this version here. Okay, Jim is going to call this version over here. And what's that going to be? Well, the first part is simply going to calculate the base amount, which means aggregates. Basically, the first course is 500 plus the second course, which is 500. That'll be 1,000. And then multiply by the premium rates for that particular object. What's the premium rate for Jim? 1.25. 1,000 times 1.25, you got this amount, 1,250. Okay, let's see very quickly for Jeremy. For Jeremy, it's going to be the same. Now, we are also seem to be calling the same method. But which version are we calling? The left or the right? The right, right? Exactly. So that means this get tuition over here, Jeremy is of type non-resident student, so calling this version over here. That means this part of the code is going to be almost the same as before. That means the first course for Jeremy is going to be 500, and the second course for Jeremy is 500. Base amount is just the same, 1,000. But in the case of non-resident students, we're going to apply discount rate. In this case, it's 0.75. So 1,000 times 0.75, you got 750. Okay, that's a very simple illustration for how things work. Okay? Any questions about this? Okay? If you understand, let's go on. That fee? Basically, we're assuming that you got the course object, right? For the course class, you got title and fee. Yeah, that's how yeah. Okay, that's exactly what I said. So we understand pretty well how things work at the runtime. But now, let's talk about issues over here. Okay? And I would like to criticize about this particular design to say if we want to make a change, since we know there's so many duplicates of the same code, for example, register and also get tuition, there's so many duplicates over there among the two classes. Whenever I decide to make a change to register, let's say I want to change the way I want to register for a course, how many places do I need to change? 2 places. Okay? Let me illustrate it to you right away. What I will do is I'll show you the kind of change I would like to have. So duplicates actually, well, this is number 1 design principle for 2030. Okay? You'll learn more about it in 3311 later in your 3rd year. Every time you see any duplicates among multiple places for your code, it's a sign about poor design for your code. Okay? And what I would like to do is, the idea is whenever you want to make a change, you may have to make more than 1 places. Okay? Let's see. The first one, let's say I would like to change the way we do register. Let's impose certain upper bounds. Let's say whenever I want to register the course for the current student, I want to make sure it does not exceed their maximum allowance. Maybe for this particular student, they can only register for 3 courses, and for other student, maybe 4, right? Just want to change the policy a little bit rather than unconditionally just register. So now the question is, only these 2 lines were actually already there, right? For the original 2 classes, but now we want to update to this. So how many places would you have to change? We got to change the resident students, also non-resident students. Let me illustrate that to you, okay, very quickly, okay, because it's really important. Okay, I'll just do 1. Okay, I'll make the source code available to you. Is it too small? Let me try to see. So let me go to resident students. Okay, it's readable. If I go to resident students over here, you can see that over here, you know what? This is the version that's already the change has been made. Okay, let's pretend it looks like this. Okay, this is what we have originally. Let me fix the other one very quickly. Okay. What I will do is, when you download the source code, you will actually see that. Okay, let me just clean it up. Okay, let's begin. Okay, we got two classes over here. For the register method, this is what we agreed on before, right? We simply register the course unconditionally and increment the counter. Similarly, for the non-resident students, we also got the same block of code. Okay, so now let's say we want to change the registration policy. If I want to change it so that whenever I try to register for the student, I would say if the number of courses of the students is already less than 5, for example. Okay, that's a new policy. If that's less than 5, then I can go ahead and make the change. Otherwise, I may have to throw some exception. Okay, I'll say throw some exception. Okay, if this is the change I want to make, am I done? Am I done with my change, or I'm not done yet? Well, I still need to modify the other class the same, right? So that means what I should do is I should really copy this code over here. Okay, if you have to do copy and paste so often, that's not a good sign for your code. That means too many duplicates. So I'll copy that and go to non-resident students and highlight it and paste. So these are the two places to change. So now again, back to the original point. What if I have 50 different student classes? In that case, I need to copy that new register method and paste 49 times. Okay, that's not a good design. Okay. Okay, let's go back there. So that's the first change. And the second one you can also try is get tuition. Let's say for every kind of student, we also want to apply something called inflation rate. Okay, so just change the way we calculate for tuition for everybody. That means you also got to make multiple changes. Okay, that's about the first drawback for the design. Basically, you got too many duplicates. It would be nice to have all the common stuff among the classes into a single place. And that's exactly what the inheritance can do for you. I will do that in just a moment. Let me say one more thing. The second drawback. Remember, we also talked about student management system. If I want to have a student management system, it's more like a point collector. In the point collector, I can have a single array of points. But now, in the case of student management system, can I have only a single array of resident students that will also allow me to store non-resident students? Well, how many arrays should I have? It seems like I need multiple arrays to maintain, right? Okay. What I meant was, over here, let's see. Okay, let's go over this code very quickly. What I meant is this. Since we got resident students and also non-resident students, they are different classes. They have nothing to do with each other. So for the case where you got this array over here, RSS, is only going to store resident students. You cannot store any non-resident students object inside this array. It's just not allowed. It's like if you have an array of points, you cannot store any account into it. Okay. Similarly, we have also a separate array called non-resident students, and in which case it only store non-resident students objects. Right. So that means we got two arrays. And then we also support 2 different counters because we may have 5 resident students. We have 10 non-resident students. So we need separate counters. And also we got 2 separate add method depending on what the type is for the parameter, right? Okay. And now, how do we say we want to register all the students, including non-residents, resident, into a common course called C? So now, how many loops do we need? Well, depending on how many array we have, right? In this case, we got 2 arrays. So we have to go over the first array over here, go over the resident students array, and then register every one of them using course. And then the second loop is going to handle all the non-resident students, in which case I'll go over this array over here and then register every student for that particular course. So I need 2 separate loops, okay? What if I have 50 kinds of students? That means I got 50 arrays, I got 50 counters, and I got 50 loops to write. That's not acceptable. Even, right? Even for beginners, you can see you don't want to do that. You deserve a much better solution. Actually, runtime, oh, actually, that's a good question. Guys, I have a question for you. Since you talk about runtime, right? Question for you. Since we got 2 loops over here, what would be the asymptotic upper bound? Are you sure n square? Should it be n or n square? Well, yeah, it's not nested, is it? Yeah, so still, runtime-wise, we are okay. It's still linear. However, what we care about right now is not really runtime, it's about internal design, right? You don't want to write 50 loops where you can just write 1. Inheritance will help you. Okay, keep this example in mind. We'll get to here possibly next Wednesday or the Monday after. We'll revisit this example again, okay? Inheritance can be such that it doesn't matter how many kinds of student you have, you just need a single array. Just need single one, okay? But we'll get there. Okay, once more, so you got 1 array here, 1 array here, and this array only store resident students, and this array only store non-resident students. You gotta go over them one by one. Okay, that's not something we want. Okay, now, so we got 2 drawbacks for without inheritance. Number 1, duplication of the code. Number 2, if you want to maintain a collection of all the relevant classes, you need too many arrays to maintain. Okay, so these are the 2 drawbacks. Now, let's see. Are you ready for inheritance? Okay, so now, so far, we haven't talked about anything about inheritance, but the 2 drawbacks we talk about can be resolved by exactly inheritance. I'll talk about only how to resolve drawback number 1, which means how can we get rid of the code duplicates, okay? For this particular example, hilariously, we have to introduce 1 more class, okay? So we got resident students, we got non-resident students. We're gonna introduce 1 more class called students. And what's the purpose for these students? You can think about everything that used to be common for resident students and non-resident students. They can be factored out to this particular students. If that's it wouldn't work. Because for now, up to now, student, resident student, and non-resident student, they have nothing to do with each other. We want to draw some connection between them. So this is a new keyword you have to learn in Java called extends. Let's get some intuition over here. If I say resident students extend students, what that means is resident students is going to inherit or is going to accumulate all the attributes, all the methods that you define in the student class. Given that everything in the student is common, so of course that can be accumulated to resident students. Similarly, non-resident student is also going to extend the students, which means everything that's common will also be inherited or accumulated to non-resident students. Okay? So that can really resolve the duplicates issue. But let's see exactly how. Okay? But now, after today, there's a new keyword you should know, which is called extends. Okay? Let's now see how we can do it. Okay? By seeing some code. There are basically 2 keywords you have to learn for inheritance. One is about extends. The other one is called super, but we'll get there. Let's have a look at the first class called students. And the purpose for the student class is everything that we identify as identical between resident students and non-resident students should be put here. In this case, what should not be here? The rates, right? The premium rates and discount rate. Very good. That means we shouldn't see that here. Now, we got name, registered courses, number of courses, right? They are all here. And also constructor, we'll see how we can reuse the constructor. Okay, the reason we're including the constructor here is because the body of the constructor is just the same among the 2 classes, okay? And also register, completely the same. So what that means is later on, if we want to change the registration policy, how many places do we have to go to change it? Just 1 place. If we got 50 kinds of students, still 1 place. Okay? Good. Get tuition. You can see that get tuition here. I'm being a little bit incomplete over here, right? I'm only calculating the base amount, which means go over the courses array over here. Let me just highlight. Go over the courses array, and then just add up the fee altogether. But now it's only base amount. But I'm going to reuse this block of code later. Okay? So far, so good. So now you'll be amazed how easy it is for the remaining part. So now how do we define the resident students class? Okay? I'll talk about parent and child in just a moment. Okay? We have a class called resident students. Now you have to draw some connection between resident students and students. You would say extend students. That's why I say you should learn this keyword. Okay? What this says is resident students is going to inherit or accumulate everything that's defined in the student class. Attributes, methods, including constructor. Okay? And then we have premium rates. That's the only thing we define as new thing. Okay? Because premium rate is only specific to resident students. And then we have a constructor here, resident students. Now, this is something I would like to show you quickly. This super here, super, you can think it this way. One thing to clarify before we get there. Okay? So now I want you to look at, maybe I'll add a new page. Okay, let's clarify some terminology very quickly. So we have a class called students. We also have a class called resident students. And this arrow here simply means extends. Okay? And so how do we call them? In this particular inheritance relation here, we'll say the one that's being extended is called a parent class or superclass. On the other hand, the one that's below, the one that extends others would be called child class, or it's called subclass. So what would be the correct way to say here? I would say students is a superclass of resident students. Also, student is a parent class of resident students. Symmetrically, you can say resident student is a child class of students. And also resident student is a subclass of students. Okay? Now, what's more? If I have, I'll get to that point a little bit later. Now, when I say, for example, let's say this. Remember, I have the student constructor, which will take a string name over here, and then I got some block of code over here. Okay? What I would do is I would say that abstractly this block of code, like a red part over here. Okay? And then the way I define the constructor for the resident student subclass is like this. I would say resident students, and it has the same parameter. And now all I have to write, in order to say I can simply reuse this block of code, how do I refer to it? Well, I want to reuse the block of code for my superclass. So what I would say is I'll simply say super. And super here, and then I will simply pass whatever argument it is needed and say name. That's done. So that means calling this at the runtime, calling this is as if I'm calling this block of code in the superclass. Okay, everybody okay? This is the syntax you want to get used to. Let me say one more thing about using the super. Remember, there was also a get tuition method. Let me say that as well. So over here, I got double get tuition. And then over here, I got also a block of code here. Let me highlight it as maybe orange, like that. How do I reuse that block of code? I also use the keyword super, but it's used a little bit differently. Okay, I'll show you. So what I would say is, I would say also here, double get tuition conceptually, what do we want? Conceptually, whatever calculation you do for the orange part is going to give me the base amount for the tuition. I want to take that value there and then apply the premium rates for this particular resident students. Agree? What I can say is, I can say, first of all, super. Super simply means go to my super class. And then dot, telling me I should really call method, I can say get tuition. So this part over here basically is reusing this block of code without explicitly writing it. And then what should I do? Well, whatever this value is, multiply by premium rates. Multiply by the premium rates. Of course, return. As easy as that. You can see there's no duplication. You just have to know how to use the super in the case of the constructor and also the super in the case of method call. Okay, any question here? Only syntax. But the concept is very straightforward. We want to refer to the block of code which we would not like to repeat at the current class. Just refer to it. Okay, okay, let's see. Let's go over the code once more. Okay, so now you can see that for the resident students class, since we know for the register method, it's not going to have any special version for this particular resident students. So we simply inherit that. So we don't need to even mention that. Okay? No mention of register. And also we got get tuition here. You can see that's exactly what I did, right? Applying the premium rate. Okay? Any question about this first class that extends the students? Okay? So now, similar to how we argued before, how would the non-resident students be defined? What should we do for the non-resident students? Same thing, right? Well, exactly. Exactly the yellow part that I highlighted, okay? So what we should do is something like this. Non-resident students, declare that and say extends the student class, okay? That means we got resident students, non-resident students, they both extend the student class, right, at the top. And we got discount rate, that's a new attribute over here at this level. And then we got non-resident students, and now we want to refer to the same version of constructor. You say super name, right? And also, get tuition, we simply get a base amount, and then we apply the discount rate instead. Okay? All right, very good. And that's exactly what I said. And that's kind of the inheritance hierarchy we have. This is very simple, but it's good enough to illustrate all the ideas we're going to talk about. I will also introduce another more complicated hierarchy where we got about 10 or 11 classes, just to get some feel. Okay, guys, up to now, any questions about inheritance? Yes?
Something extends to resident students is also extended.
What do you mean?
So if you have a new class that extends to resident students, right?
Okay, and then? Mm-hmm.
Then if you change something in the student.
Okay, very good. Let me explain that. I like that. Okay. Let me just say one more thing. Okay. So what we have is this. Students we got resident students and also non-resident students being subclasses. So there are two subclasses of students, and also these RS and NRS, they have the same parent class. Now, back to your question. Let's say this. I have my register method defined over here, right? And then I got some code over here. Since I did not explicitly declare register in either of the classes, that means this block of code is inherited verbatim into over here automatically. Okay? Now, what if I make a small change to here? Well, because of inheritance, whatever change I made over here is going to be reflected directly to here. That's inherited. So that's the only place you have the change. Okay, I'm just trying to illustrate to you. Okay? Okay. Maybe that kind of answer your question, right? If you make a change.
Would it get something
Oh,
attached to
the same. So now if I got another class, let's say, I would say RS2, for example. So now in this case, of course, this gets a little bit complicated, but the principles still apply. this register method is inherited to here, and also that one is also inherited here as well, so the same version. So if I make any change over here, then it will be reflected. Unless, a little bit like an equals method. Remember we said, if we did not override the default equals method from the object class, it's going to stay the same for the comparing the references. If we choose to override the method, it's going to be a customized version. So that's something that will apply to here as well. But we'll talk about it a little bit later. Okay? Questions? Yeah. Oh, good question. The question was, when I say something like this, let's say in RS2, let's say in some method, when I say super, which class am I referring to? Okay? Okay, super, you can think about super is only one level, so only this level here. But in this case, I don't want to get too complicated, but in this case, since I define the various version of register at a student level, and that version there is inherited verbatim to here. And now, so when I say super dot register, for example, some course C, it's simply just going to call this version, which is effectively this version over here. Okay? Good. Yeah, but we'll get there. Yes. Yeah, very good. Okay, so now parent superclass and child subclass. Okay, so now let me just go over this slide very quickly. So we have seen all of them already. Let's just go over. So what can inheritance really help you? So when we move on the poor design to the good design using inheritance, you can define common attributes and methods in a separate class. For example, student class. And then we can also we can create the extended version. Extended version means there are two things you can do for extension. So this is really important. One extension can be you just add new methods, or you can add new attributes. For example, in the case of resident students, we're adding a new attribute called premium rates, which does not exist in the student class. Okay? And what's really more important, okay, first of all, we inherit everything from the parent class, name, register courses, number of courses. These are all inherited. Yes? You know what? Good question. The question was, what if the methods are private? The answer is no, they will not be inherited. But for now, let's not worry about private methods. Okay? So just to make our discussion a bit easier. Okay? Let's now assume that everything from the parent class is going to be inherited. Okay? I will talk about more like a private or even protected that you may have known about. So we'll talk about it a little bit later. Okay, okay, we got name, register courses, number of courses, and also we can define new attributes and new methods. For example, in the case of the resident student, we can set the premium rates or the premium rate attributes, right? In the case of non-resident student, we got discount rate. Okay, that's a new one. Now, the third kind is really the tricky one. For example, let's say this. Conceptually, you can think about we have get tuition that's defined in the student class, right? And then we definitely want to inherit part of it into the resident students. We also want to inherit into here as well. We want to. But at the same time, want to do something extra. For example, in the case of RS, we want to apply whatever value it is for the get tuition from the parent class by the premium rates. In the case of non-resident student, we want to apply the discount rate to that. So in this case, it's not exactly inheriting. We are overriding. Okay? So now I'll just make one example here. We are overriding or redefining. Overriding get tuition inherited from students with the calculation of discount rate. Discount rate. Okay, that's overriding. But we'll see more overriding a little bit later. Okay, guys, any question about this? We okay, right? Okay, so that means there are two kinds of extension you can do in the subclass. You can either introduce new stuff, or you can override the inherited stuff. Okay? Yes, go ahead. Static. Good question. What about static? Static, very briefly, static belongs to the class rather than the instances. So I would say it does not really quite apply to our discussion over here. I would say don't worry about it. Yeah, don't worry about static.
We know that a class I define in the, let's say, parent class is gonna be rewritten by all the subclass of it. Should we just still write it in the parent class?
I don't quite get what you mean. You want to say that again?
So like we have something in the parent class.
Yep.
And we do not add any like inside method of that method, and because we know every subclass this parent class has, it's gonna rewrite it.
Okay, what you're saying is, let's say this. Let's say we have a class called A, the parent class. Let's say we have a method called M. You're saying that we simply leave the body just empty, right? Like that. Okay? And then you simply say over here, I have a class called B, I have a class called C. And then since B and C is going to inherit this empty version of the method N, which is not very useful. So that means we can override it by simply say N, and then we can add some stuff over here, and N, we can add some stuff over here. That's what you meant, right? Yeah, I would say that's okay, that will work. However, this is not a very good use of inheritance in this way. What you want to do instead is to do something called abstract class, which we'll get into after all the discussion about polymorphism and binding. Okay, good. Okay, we define overrides. I would say this slide is really important. Okay, basically summarizes what we did so far. Now, let's see. Now, in order for our discussion later to really be smooth, let's think about how we can visualize the objects, especially now we got inheritance. Okay? I do have a picture on the slide. You can look at that later, but I would like to draw for you. How do we visualize objects like this? For example, I got three objects over here. I got S, I got RS, I got NRS. Okay? Guys, remember I said something about static type? When we talk about equals method, I promise we'll talk about it. Now is the time. Okay? Whenever you try to declare a reference variable, the type that I put over here is called static type. Okay? Static type. How do we tell the static type? Very easy. Go to the declaration for the variable and see whatever type it is. That's a static type. And static type never change. Never ever changes. That's why it's called static. Okay? Now, how can a static type help us? The way we visualize the object at the runtime basically tells us what kind of attribute we should include in the box. Right? Now, for this particular object over here, we know that for S, it's going to point to some objects of type students. We know that. But now, what kind of attribute should we include? What should we include over there? We should include name. We should include registered courses. We should include number of courses, right? So anything else for attributes? That's it. Should we include premium rates? No, they only exist in the subclass level, right? So that means we should only put name, courses, and number of courses. Okay, of course, there can be some value over here. So far, so good? Now, let's get to RS. RS, from the declaration line, we know that the static type in green for RS is resident students. So what I'm going to draw is, I would say RS is going to point to, we know that we're going to create some resident students objects. I'll say RS for resident students. Now, how many attributes should we put? How do you know it's 4? Because for resident students over here, there's only one attribute here. Also, you're going to inherit all the attributes from the parent class, right? That's the tricky bits. So in this hierarchy over here, we only got one parent class, which means all the attributes over here should be inherited as part of the attributes at the runtime for this subclass. That means at the runtime, this is what we have. We got name, we got courses, we got number of courses, and we got premium rates. Okay? Be even more explicit to you, these three attributes are inherited from students. And this part here is new to resident students. So 4 in total. So the trick is, even though in the declaration of these resident students, you don't see those 3, but they are in the parent class. Let me give you one practice. If I have a hierarchy like this, A, B, and C. Okay, let's say make it easy, A1, A2, A3, A4. So the attribute A1, A2, A3, A4 I put there, simply I only declare those attributes at that level. Okay, now, let's say at the runtime, how many attributes does C have? Which 2? A1, A3, right? A1 and A3. Similarly, what about for D? How many attributes do we have? 3, okay, we got A4 itself from its superclass, from the superclass of its superclass, which is A1. So when I say the superclass of its superclass, it sounds very funny. It's called ancestor class, ancestor. I will get there next Monday. Okay, that's about it. Okay, now let's go back here. So now you get an idea how to visualize it. So now let's do one more. Now, if I try to visualize NRS, and the static type is non-resident students, and then I try the following. NRS is pointing to some non-resident students objects, and now how many attributes do I have? 4, right? Those that are inherited from the student class and courses, number of courses, and discount rate. Thank you. Discount rate. That's it. Let me go one step further. Given that we know how to visualize these objects, if there is an object, if there's an attribute over there, that means we can get access to that particular object, right? What that means is, thinking this way. For S over here, given that we only got 3 attributes over here, if I say S dot and S dot name, that should compile, right? If I say S dot courses, that should also compile. If I say S dot number of courses, that should also compile. What if I say S dot premium rates? It shouldn't compile, right? So there are 2 aspects to this. First of all, how does Eclipse or the Java compiler tell that this shouldn't compile? I'll give you a little bit quick preview. When the Java compiler sees this line, what it does is very simple. What's this variable? Where is this variable declared? This line. What's its static type? Students. Static type is students. And for the student class, we know that it has name, courses, number of courses. And PR is not one of them, so should not compile. That's the decision process for the compiler. Okay? And one more thing to say. We call that the list of, and similarly, for the methods, can we say S dot register? Well, is register defined? Yeah. So that's why we can also say S dot register. Can we say S dot get tuition? That's also fine. Can we say S dot set premium rates? No, nothing to do with the student class. Okay, now, one thing to say. We call that the list of attributes and methods that you can call on a particular type, in this case, students. Let me just call that the expectation. The blue one over here is called the expectation on the static type of students. Let's practice thoroughly. All right? This is going to, now we are basically moving out of something about code reuse. I'm trying to make a smooth transition over here. Basically, you want to know how to visualize the objects by looking at what attributes and methods are being inherited. So you would know what methods and attribute you can call on a particular variable. And I called it the list of methods and attributes you can call the expectation. Expectation is going to be the basis for discussion for the whole week next week. Okay, let's do it all together and make sure we understand it properly. Let me, again, for completeness, let me make sure you follow 100%. So now we got this inheritance hierarchy over here. We got students, in which case we define name, registered courses, I would say CS, and also number of courses, I would say NOC. And also we got register method, we also got get tuition. So these are basically expectation for any objects of static type students. That means any reference variable declared as student type, you can call these attributes and methods. Now, let's have a look at, for example, for the resident students class over here. For resident students class, we know that we definitely are going to inherit the name, register courses, number of courses, register, and get tuition. So these are the base expectation. I'm going to add something on top. What's going to be the thing we add on top? Well, premium rates, and also set premium rates. And well, get tuition is already there. So the pink one is the expectation for resident students. What about the expectation for non-resident students? Well, let me use orange. Name for sure, register courses, number of courses, register, get tuition, what else? Well, discount rate and set discount rate. So these are the expectation. So see you next week. So once we know about the expectation over here, let's think about the last discussion for this for today. Okay. Now let's fill up all this table together. Let's be the compiler. Okay. Let me try to tell you how you can read this. I'm basically saying for S, I declare that to be of static type students. For RS, I declare that to be of type resident students. For NRS, I declare that to be of static type non-resident students. That's how we begin with. Okay? And now, if I have the context objects being S, can I say S.name? Can I? Yep, okay. If I can, I'll put green over here. Okay, what about S.RCS? Register courses. Should be all right? What about S.number of courses? Good, thank you. S.register. S.get tuition. Good, so far so good. What about S.premium rates? No, right? It's only defined in the subclass level. So what I will do is I will do red. S.set premium rates? Nope. S.dr, discount rate? Nope. S.set discount rate? No, right? Good. You get the idea. Let's go to the second row, which is more interesting. For the second row over here, what about RS over here? RS is, I shouldn't use this color to confuse. RS was declared of resident students, and we know about its expectation already. If the thing you're calling is within that particular expectation, it will compile. Otherwise, it does not compile. It might be easier to tell me which row will not compile, which column will not compile. How many columns in this row will not compile? Two? Which two? DR and set DR, right? So that means I can simply do something like this, and the rest are simply green. That makes sense because everything inherited from students I can call resident students. Everything that's added to the resident student I can also call. Okay? What about final row? Okay, for that one there, how many wouldn't compile? How many columns? Two. The same two or different two? All right, which two? PR and set PR, right? And the rest will definitely compile, right? Whatever is inherited from students and these two. Okay, guys, are we okay? So now, before Monday, all you have to do is review students, resident student, non-resident student, make sure you know about the attributes, methods, and also know about expectation. because the thing we're going to talk about next Monday and Wednesday are hard, very hard. Next Monday and Monday and Wednesday, right? Lab test is not in lecture time, right? Yeah. Okay, but I would say all you got to do for next Monday for preparation, review this table here, and then we'll start from here. All right? I'll see you next Monday.